Hi everyone. This video is going to be about the intervertebral discs and ligaments and some other structures within the spine. So let's start in our book. We're going to start with the ligamentum nuchae. I know we've already gone over the ligamentum nuchae, but it doesn't hurt to review. So this is page 218 in your book. Remember that the ligamentum nuchae is a fin-like ligament that attaches to the spinous processes of the cervical vertebrae. If you recall, the spinous processes on the cervical vertebrae are bifurcated. Remember, they're forked. So that is the attachment area for the ligamentum nuchae. And the ligamentum nuchae really stabilizes the head and neck. If you think about it, you have a bowling ball attached to a broom handle. So if the bowling ball goes one way, it would fall over or fall off. If it went the other way, it would fall off. You get the idea. So the ligamentum nuchae is a stabilizing ligament for the head and neck. And it also serves as muscle attachment sites for trapezius and splenius, capitis, and the like, okay? We cannot really palpate the ligamentum nuchae exactly. It's hard to distinguish what we're feeling when we're palpating along the spinous processes in the posterior neck, but it is there and it actually is palpable. Okay, so the supraspinous ligament actually runs the length from the ligamentum nuchae down to the lumbar vertebrae. So the supraspinous ligament is sort of an extension of the ligamentum nuchae, if you want to think of it that way, because it runs along the spinous processes. So spinous process to spinous process to spinous process, and you can see that here. Okay. All the way down the spinous processes. So again, this is a stabilizing type of ligament, and we have a lot of stabilizing ligaments for the spine because otherwise it would be just a little bit too mobile, and we can't really have that. We have to be able to stay upright, and we have to be able to move and keep our spines relatively in the same position in order to prevent injury to the spinal cord and to the exiting spinal nerves. This next illustration is the abdominal aorta. The aorta, as I mentioned in the video on the diaphragm, is the largest artery in the body. It carries blood directly away from the heart, down the back of the heart, down in through the thorax and into the abdomen, where it splits off right around the belly button into major arteries here and here that supply the legs with fresh blood. You can sometimes palpate the pulse of the artery, and sometimes you can feel it in yourself. Like if you push in to your own belly just above the umbilicus, you can feel the pulse of the aorta. This is the same type of general rule that I mentioned with all arteries. If you feel a pulse, get off of it, okay? You do not want to be on the aorta at all. Unless you're working directly on the abdominals, specifically rectus abdominis, you don't really need to worry about the aorta, okay? I have mentioned the thoracolumbar fascia before, thoracolumbar aponeurosis, that broad, flat tendinous sheath out of which latissimus dorsi and several other muscles arise, specifically the erectors down in here, okay? This is a good illustration so you can see exactly what it looks like when all of the muscles are in place, okay? It is tough, it's thick, fibrous in the posterior lumbar area. Fun fact about a giraffe, I love this. A giraffe has the same number of vertebrae in their neck as we do in our neck. 7 cervical vertebrae has the giraffe. They're just really, really big. I think that's a fantastic fun fact. Okay, I'm not going to go over all of the ligaments here. I do want you to see, though, not this one. Yeah. It's on the next page. Okay, here we are. I want you to see how the vertebrae are held together with ligament. So you have all ligament that runs the entire length of the anterior vertebrae, called the anterior longitudinal ligament. It's this one here, okay? And it holds the vertebrae in place on the anterior side. Then you have a posterior longitudinal ligament, and it holds all the vertebrae in place on the posterior side. So you have these intervertebral discs in between each vertebrae that are held in place by, cartilage that attaches to the bone, but also on either side by ligament, okay? Here's the supraspinous ligament, again, more vertical. And you actually have, in between each lamina, you have ligament called ligamentum flavum, okay? So these are stabilizing ligaments, and they help to keep the lamina from coming too close together. Again, everything has to keep its spacing in the vertebrae because you need these openings here. These are the openings through which the vertebral nerves, the exiting spinal nerves, they exit off of the spinal cord out through these holes, and then of course they go all over the body, and become smaller and smaller and finer until they reach their destinations. But without this space here, those exiting spinal nerves are compressed, and that causes pain and dysfunction to whatever is down the line on that nerve, okay? So these ligaments are really important to help stabilize and maintain the space for those exiting spinal nerves. Here's another view of the ligamentum flavum. Okay, just giving you an idea of what you're looking at here. Transverse process. The body of the vertebrae really have been taken off. Okay. Here's another view of that posterior longitudinal ligament. See how it stabilizes the whole thing, and it actually has extensions of it out and around the disc. Okay. All right. Flavum means yellow in Latin, in case you were wondering. Ligamentum flavum is yellow. All right, so that's just a little bit about the ligaments and how they help stabilize the spine. I want to talk a little bit about the intervertebral disc. So let's show you what they look like. Okay, so here's an actual picture of the intervertebral disc. This is a real one. And this is the inside of a real one. Okay. The intervertebral disc is structured very much like a jelly donut. Okay. The outside bit here is called the annulus fibrosus. And I put my little cursor right up here. The annulus fibrosus. It's made of fibrocartilage, and it's super tough, hard to tear, it's dense. On the inside here, this yellowish bit, and it's yellow here too. This is called the nucleus pulposus, or pulpy nucleus. And that's exactly what it is. It's squishy. It's the jelly of the jelly donut, okay? And this nucleus pulposus is supposed to be encased within the annulus. Now, this is like a jelly donut or like a water balloon or whatever kind of analogy you want to use. You can visualize the concept that this is used as a shock absorber, okay? So when you jump up and down or when you step heavy, your vertebrae are going to want to come together. But instead, you have this lovely jelly donut in the middle that's absorbing and dissipating some of that shock so that you don't crack your vertebrae. That's pretty important. So let's take a look at another picture. Some of these have the nucleus being just a little tiny bit. Some of them have the nucleus being rather large. It doesn't really matter. You just get the concept, okay? The disc is held in place with ligament. You saw that on either side. However, this right here is the spinal cord. And these yellow things on either side are the exiting spinal nerves. You see how close they are to the disc? Yeah, that can be a problem. And let me see if I can bring up a picture of a herniated disc, because we're going to be talking about this in the disorders. Yes. So here's the idea. I'll bring this one up. Here's the idea with a herniated disc, okay? The nucleus pulposus shifts or gets squished somehow, like if you stepped on just one half of the jelly donut, all of the jelly would squish to one side, right? Well, that's kind of the idea here. And technically, a hernia is a hole. That's what the word means. So you would actually have some of this nucleus pulposus leaking out. So there'd be a tear in the annulus fibrosus somewhere, even if it's just a tiny tear. And then you'd get some of this nuclear material leaking out into the space next to the spinal cord. If it's not leaking out, if it's just kind of misshapen and pushing against the nerve root here, then it's a bulging disc, okay? It's pushing against the nerve root, it's bulging into the nerve root. Sometimes it'll bulge posteriorly, sometimes it'll bulge anteriorly. It depends on where that bulge is or where that squished bit is as to whether or not you have any symptoms. Because obviously you're going to have symptoms if it's pushing into the nerve root. It's going to hurt the nerve root. You're going to feel that. If it's pushing anteriorly, you might not, okay? But that's the idea of herniation or a bulge. You can see that the nucleus actually squishes to one side or gets moved a little bit into the annulus, and sometimes the annulus actually breaks, okay? So I wanted to talk about the structure of a disc before we talk about disorders, because you do have herniated disc and bulging disc as part of your disorders. You also have things like stenosis and ankylosing spondylitis, which don't involve the disc specifically, but the discs will be affected by those disorders, okay? So next up, disorders of the spine.